Water sources, as we also discussed about the water sources in a previous class. So I will just go through just somewhat fast. Okay. First of all, the, in order to design a water supply system, you have to choose the right water source for the design of water supply system. Mostly it is well and good if the source is available in the vicinity of that area, because it is very economical to choose the water supply, to choose the source of water. It may be the river, the stream, or groundwater, spring, pond, whatever it is. So it should be very economical if it is available in the proximity of area. The source must ensure a reliable supply up to design horizon. For example, if you want to design a water supply system for 30 years, so the quantity of water and the seasonality that occurs in that source of water throughout the year should be such that it should fulfill the design criteria or fulfill the demand of that water supply of that community for that 30 or 35 years. In case if the single source is not available, then 2 or 3 sources can also be selected. For example, you can also select the stream with the combination of groundwater, with the combination of pond, spring, something like that. You should quantify the capacity of each source before selecting the source, because for example, if one source is available in the vicinity of a water supply system, but it only provides fulfill the demand up to 10 years, then other sources should also be measured in such a way that for example, if the source is not commissioning after 10 years, then other sources should be provided in, and should be designed before the commissioning of that water supply system. And after 10 years, that the second source should be operable for the supply of water to that system. So investigation prior to defining the water resources. So investigation is very important to quantify the quality of the water in the water supply system, the seasonality, the variation through seasons in a source, how it varies the water level in that source, the admissible water quality, water quantity for exploitation has to be identified for each specific source on the basis of hydrogeological and hydrological investigations. So basically, this type geological and hydrological investigation is such that mostly in areas where the rainfalls occurring most frequently, so the groundwater so resources charges very rapidly. So mostly in this area like Swat, Kalam, Dir, so the water availability is very high. So mostly the one or two sources are most sufficient in order to provide the water for the community for the design horizon. Okay. So first of all, you have to identify possible sources, collecting available information about the location, elevation, water quantity. I have shown you the different methodology to measure the quantity of water or the flow rate of water to that flow rate, for example, for the stream or river. For the groundwater, how to measure the quantity of groundwater. Similarly, for the pond, for the spring. So these are the different types of methodologies mostly used for to identify water quantity. Mostly, if you want to measure the water quantity and also measure the variations seasonally of that source, so that you have to perform the survey for throughout the year in order to know about how the water varies to that source. The quality should also be measured, because if the quality is not viable, then the treatment should be preferred based on that quality, how much contaminations or contaminants is present in that source of water. Okay, the assessing possible sources of pollution. So you should know that what type of contaminants are occurring in that water source if the quality is not viable. the rate of usage of these sources, avoid over exploitation and conflict with other users as well. Mostly in our cases, we are over exploiting our sources, and in Hyderabad, I know that the groundwater goes deeply about 250 feet or about 300 feet in a previous 20 years. So we have to avoid that over exploitation of water. Otherwise, we will face difficulties and problems in the future. Cultural aspect to be taken into account. So, in the context of Islam, we mostly we have to consider the water available for the prayer purposes and other purposes like that. So that type of cultural aspects should be taken into account in order to design the water supply system as well. By carrying out these possibilities are limited. So I have also discussed with you that it should be surveyed for 1 year. If there is availability is not fulfilling the demand, then other sources should also be measured and selected in order to design in order to fulfill the demand of water supply or the community. So these we also discuss. Okay, if you identify the different type of sources, the quantity, the quality, and also keeping in mind the economic consideration, so you have to rank these different types of sources, that what type of source will be viable for the designing of water supply system. So mostly, if for example, if there is industry, factories, and offices, and also the residential area, so for example, you can choose the different type of sources for groundwater for the drinking purposes, and the stream or rivers are if available in the vicinity of that area can also be used. That water can be used for the industrial purposes or for the factories for the production of different things in that industries or factories. So if that quality of what is not viable, the treatment should be provided. Ultra ultrafiltration plant and chlorination should be provided in order to get the good quality of water. Okay, in order to design the tube wells, the entrance velocity should not be greater than 0.05 feet per second, because if the velocity greater than the sands and other particle like that moves through the pipes and cause the blockage of pipes, if the rate of that sand or the quantity of that sand increasing day by day, it causes the blockage of pipes and causing the increasing the pressure in that pipe and may cause the busting of pipe. Similarly, the strainer should also be provided mm, at the end of the tube well. Let me 0.05 feet per second. This is the entrance velocity for the tube well design criteria. Okay, let me open the diagram I want to show you. Okay, so basically this tube well is a rising man casing is provided throughout this rising man. The gravel pack at the end is provided that the sands and other particles like that cannot be entered into that tube well. So it's aquifer, that is a tailpipe. The strainer is provided at that end, and the velocity or the entrance part decreases up to 10% of that dia of pipe according to the standard, in that the water or the water enter into the pipe, but the particles like sands should not enter into that rising man, in order to prevent the blockage of pipes. Sanitary steel are provided at the side of that casing in order to the deterioration of water or contamination that may contaminate the water or may cause the rusting or other stuff like that of that casing. So it's a borehole. The pump head it also provide the upper end. So it's basically the schematic diagram of the tube well. So let me share the again the design criteria of WASA. Okay, the opening area of standard should be 10 to 20%. To lower the limit of 10% is recommended for the design purposes. Slot sizes is recommended for a screen. Shrouding shall be provided. Shrouding is basically the gravel provided at the side of the casing. House pipe or the rising man is basically rising man is the house pipe. The diameter of house pipe will be based on the design discharge of tube well. So depending upon the demand, we provided a pump or or based on that we provided the rising band in order to get the or sucks the water and then provided into the system. Sanitary steel is provided to control and check the surface and ground contamination and shallow depths. Sanitary steel consisting of mostly 1:2:4. Plain concrete is provided. So as I have showed you that what is the sanitary steel provided at the upper end at the side of the casing. Shrouded materials is the gravel material basically of 1/8 inches to the 3/8 inches of gravel should be provided, and its thickness will be in the range of 3 inches to 6 inches. Shrouding pipe should also be provided if it's viable. There shrouding shall be done through 3-inch diameter PVC pipe or equivalent. Suitable walls of the perimeter should also be carefully selected. Delivery pipe length of delivery pipe is basically one is the rising man, which is basically sucks the water, and other is this after sucking which delivers the water that in a pipe is called the delivery pipes. So the length may vary about 6 to 9 feet. So let me show you in the diagram. Where is the tube well? So basically, this is a delivery pipe which delivers the pipe to the water supply system. So flow meter can also be installed in order to measure the how much flow is flowing through that delivery pipe by measuring the pressure head. So different types of storage can also be selected depending upon the Ataulata sudah mic ban ke. Okay. Different types of water supply system or a storage or different type of network should be provided depending upon the demand. So the bulk water transmission system, the size may varies and the material may vary depending upon the demand. The storage reservoirs, it may be elevated, it may be ground, it may be sump. Intermediate storage is the reservoir may be provided mostly in the hilly areas, distribution network, terminal, consumer installations. So mostly for the terminal pressure, about at least 6 meter of minimal meter of terminal pressure or and about 65 meter of maximum terminal pressure to be provided at each junction. For rural residential area, the existing standard, the maximum terminal pressure is the standard of terminal pressure. It doesn't talk about the maximum minimum. So it's not clear that it is the minimum value or the maximum value. So, okay. So for the urban areas, 6 meters should be provided up to a minimum, and 65 meter of maximum value should be provided. So it's basically the water that, for example, is a junction, different types of pipe connected. So minimum means that the water should be minimum rise about 6 meters if we open that, or if we install a piezometer at that end. So the water should rise up to 6 meters at that junction. Velocity of pipe should not be greater than 2 meter per second or less than 0.5 meter per second. By increasing the velocity, the pressure decreases, and by decreasing the velocity, the different problems like the siltation, siltation, siltation. Something here. Okay. Just to explain like that. For example, the velocity too low, so the particles may from the tubes that it may cause the sand particle, the lowering of that particle can cause the blockage of a pipe. So too much low velocity are also not viable. Um, so by decreasing the too much velocity, the pressure becomes very high. It may cause the bursting of pipe. So rising main 0.3 meter to 2 meter per second, but for long rising mains life cycle cost naturally not different. Okay, so the proper rising main should also be selected based depending upon the demand of a water supply system of or a community, and the velocity in that pipe should also be less than greater than 0.3 and less than 2 meters per second. Earth covers over a pipe, it maybe varies, but a minimum of 36 inch must be provided from the top of pipe to the established finished grade above the pipe. However, all the road cuts are to be filled in with paved sand or river sand during design site layout or other infrastructure. For example, the storm sewer and wave definitely sewers should be considered in minimizing to need to have deep pressure mains. PSPs, the public stand post, should not be provided in urban areas. Mostly in urban areas, water supply network is only provided in CB urban areas and peri-urban areas. The location of stand post shall be made in such a way approximately in about the for a community in the rural areas. It should be provided about in the 350 feet of their end consumers and should fulfill the demand of 200 person. And in context of India, it is about 250%. So PSP to be provided only after study of revenue collection data of concerned area. So basically, water you can identify or the water demand in that area where the stand was used just by a number of people giving money to the government. Based on that stand post, we can calculate that how much people or how much number of person are using or what are the demand of that area. Minimum size for the distribution network should be 3 inches and maximum it can be it may go higher depending upon the demand. Pipe material to be used shall conform the standard given. So these are the different standards used for the selecting pipe material. So according to ASTM, then I don't know about then, but the BS is the British standard. Service connection, if you are providing a connection to the household, so the pipe size of 1 by 2 inch half inch pipe should be used, and for the commercial connection, so 0.75 inch pipe of should be used for the service connection. So galvanized iron pipe and other pipe like PVC can also be used for the service connection. Cast iron pipes can also be used. Sluice valves will be located at main control points, mostly for use for the controlling of flow, and non-return valves are mostly used in the tanks and also be used in the tubules and for the rising mains and for the high diameter transmission lines in order to prevent the backflow of water through the pipe. So mostly, for example, if you have a tank and you have rising mains and you are pumping a water to that tank, so in order to provide the backflow of water, so we provide non-return valve here or check valve in the tank. And similarly, in the case of tube wells where we sucks the water, so we don't want to that the water should not go in the back direction. So therefore, we provide a check valve in order to prevent the backflow of water. Air release valves are provided at the summits, at the high mostly in the hilly areas like that I explained earlier, and after 2 kilometers intervals in a speed free areas should also be provided in order to release the ears to prevent the vapor pressure in that pipes. So cast iron pipes is the best for the material for the air relief valve. Washout to be located at the lowest point to wash out all kind of debris. Washout or the plugs or the sluice valves mostly at the dead ends are installed in order to remove the water at the dead ends. Storage reservoirs, overhead reservoirs, groundwater reservoir, and water metering. So I think I don't need to discuss. I have already discussed with you these type of stuff. So that's it for the first lecture. If you are willing, good, then we can take a second lecture as well. تاسو وایي جی خالد بھائی احمد بھائی څه کوېشن یو وایي څه کوېشن خو ځان دومره نه ټول تیوري ده او دویم کلاس اخلي کو نه Elizabeth, will you want to take a second class?
I am ready to take the second one, and we can read out this letter, and if you have any question, we may ask you in WhatsApp group.
Thanks. Willings, are you willing to take a second class?
Yeah, no problem.
Okay. Let's start another session, and then we will start Watergem. الطاولة ته کې مسله ده جی او تاسو څه کارونه دي طاوله بای
یاره اصل کې د ورځې چې کوم دی نو مختلف کارونه راځي که او که نه بس
نه یو ګنټه نشي فارغې دی
صحیح ده زه به خیر ریکارډینګ هم ګورم ستاسو ریکارډینګ ډېر زبردست دي صحیح شو نشته بیا وروسته هم ډسکس کولی شو چې نور څوک ټول فارغ وي که نه
زه چې دا کلاس والم او ما ته لږ نور کارونه دي هغه راغونډوم
ټول والې ښه ماته هېڅ شو نشته صحیح ده څونه ما کتلی شو وګورم بیا به
بس څونه پر تاسو فری یې بس کلاس کې اوسئ او بس بیا تاسو صحیح ده جي زه بل سیشن سٹارټ کوم صحیح ده السلام علیکم